Hi, here is a beautiful proof for the square root of 5 to be irrational number. In order to prove square root of 5 is irrational number, we are going to assume square root of 5 is a rational number, then we drive towards contradiction. Okay? Let's suppose that square root of 5 is a rational number, which is written on this form: a over b. A and b are the natural numbers. Okay. So this implies GCD of a b equal to 1. That's mean greatest common divisor of a b equal to 1. That's mean a can divide by 1 and b can divide by 1. There is no common factor except number 1. There is no common divisor. There is no common divisor except number 1. Okay, so we have square root of 5 equal to a over b. This equivalent a square equal to 5. I'm going to square both sides, so I will have a square equal to 5 is multiplied by b square. Okay, now we are going to do two cases. When we have a is an even number and a is an odd number. Let's start with the first case, which is a is an even number. A is an even number. This one implies a square is an even number. This implies b square is an even number. Okay, that's mean b is an even number. Okay, so now a and b are even. Okay, since a different than b. Okay, otherwise a over b equal to 1. Okay, so this implies GCD, greatest common divisor of this number a and b, are superior or equal to 2. In the other words, a and b are shared number 2 as a greatest common divisor because they are even. Okay, since we found GCD of both numbers equal to 1, in the same time we found GCD is superior or equal to 2. That's mean this assumption contradicts this. That's mean a must be an odd number. A is an odd. This implies a can be written on this form: a equal to 2k minus 1. You can write it as a 2k minus 1 or 2k plus 1. Since we have a is an odd number, that's mean a square is an odd number as well. So that's mean 5b square is an odd. This one implies b must be an odd number. Okay, this implies b can be written on this form: 2l minus 1. Okay, what I'm going to do now, I'm going to replace these values into this original equation. So this implies, so that's a square, which is 2k minus 1 quinary square, equal to 5 times 2l minus 1 quinary square. It's equivalent 2k minus 1 quinary square minus 2l minus 1 quinary square equal to 4 times 2l minus 1 quinary square. What I did here, I just brought one of those 2l minus 1 quinary square to the other side. I will be left with 4 times 2l minus 1 quinary square instead 5 times. Okay, instead 5 times 2l minus 1 quinary square. So I'm going to apply the identity: a square minus b square equal to a minus b factor a plus b. Okay, so I will have 2k minus 1 minus 2l plus 1 factor 2k minus 1 plus 2l minus 1. So this one is giving me 4 times 2l minus 1 quantity square. Okay, so I'm going to simplify this one. So I will have the number 1 will be cancelled out. I'm going to multiply, I'm going to take number 2 as a multiplier than first term. So I will have 2 times k minus l. I'm going to take number 2 outside as a multiplier from the second term. So I will have 2 is multiplied by 2, factor k plus l minus 1. With this number 2 multiplied by 2 is giving us 4 times. So I can put it 4 times here. With this 4 times, 2l minus 1 quantity square. So number 4 will be cancelled out. Okay, I'm going to bring this one at the top and continue with our problem. Now in the last board I was working on odd number and came up with this expression. So I have this expression equal to 2l minus 1 quantity square. We have this number, it was odd number. Okay, since this one is an odd number, that's mean the quantity square of this one number. So that's mean the square of this odd number is giving us odd number. That's mean this product is an odd number. Since this product is an odd number, so that's mean this term must be odd. Okay, since this one is odd, this implies k must be odd and l must be even, because the difference of k minus l to be as an odd number, k must be odd, l must be even, because this implies k plus l is odd as well, because odd plus even is giving us always odd. Since k plus l is odd, that's mean implies k plus l minus 1 is even. That's mean that this is even. Okay, this is odd. Even is the product of odd and even is giving you always even. The product of odd and even is always giving you even. But here the same product equal to odd. This means this is wrong. Okay, thus square root of 5 is irrational number. Irrational. Okay, so I have done with this problem. Just consider the subscribes. Thank you for watching. I will see you in next video. Bye.